this on my computer. And then I will start this recording as well. All those who ask, anyone who asks questions as well, or the person that asked the question earlier, thank you so much for the question. I think it's also quite timely as well, because what we're planning to do today is to have a look at other machine learning algorithms. It wasn't originally sort of what we are planned to deliver, but I think we think it's necessary that we do this. So we will walk through it. Pretty much, you can tell from previous weeks that we have been looking at various machine learning algorithms. We've looked mostly at regression, and we did look at linear regression, and we have also looked at logistic regression as well. But then, of course, as we go on, we will again look at where they fall on the map, right? So in doing so, we've got, we'll be focusing on some of the popular machine learning algorithms, and that will take us to look at, again, my machine has froze, so I'll give it a second. Taking more than a second this time. Yes, it's back. So that will take us to look at decision trees, and then we will have a look at k-nearest neighbor, and that's where we'll be sort of stopping today. And we'll just do a quick recap of k-nearest neighbor, and we'll have a look at k-means, and then also naive as well in our next session. If we do get the chance to do a lab, but I believe that the plan has changed slightly, so we will do a lab, but not necessarily on something on support vector machines. We will most likely make it available to you as an optional thing that you would do. If we are doing that, I'll find time to create an accompanying video for you as well to use as an additional resource. Can I double check at least you're okay with you understand each word clearly rather than the, in terms of the way I'm speaking?
Yes, we can. Yes, we can.
Okay, so we take this pace then. So again, we've seen this particular map quite a number of times, and we have seen some of these algorithms before, and we've tried them practically as well. So basically, we've touched on regression and we've touched on classification. Okay. For what we'll be doing today, yes, of course, they fall under supervised learning. We also, from some of the things we've mentioned, you notice the k-means actually sits somewhere there, which is also an unsupervised learning. So in terms of some of the things that we will be looking at later, we will also touch on supervised learning as well. But then if we take our task for today, we want to take the classification. So we know we've gone through machine learning, the classical, the most common ones, then we've gone to supervised, and then we've dug a bit more. We just want to do something similar to what we've done at this particular point, and we're saying that we're going to take the classification and sort of split it, so we can have a further subgrouping, right? Just bear in mind that all we're doing is we're doing further subgrouping, and we're going to take some of these algorithms to see which some of them, which one actually form under maybe, let's call it, give it a random name, right? For now, just for now, we just call it A or B. Normally A goes first, but let's call it A or B for now. So we see which ones fall there, and then we just have a look at some of the algorithm just to figure it out. But with regression, we'll just let it sit as it is now. So we're just doing one step in terms of subgrouping, okay? And of course, we did have a similar sort of a question in the previous thing, which I think we can't preempt right now, is that when we talk about the classification, we're just simply doing some subgrouping under there, the same way we've done subgroupings on here, okay?
Okay.
So we want to start off with an example application. So basically this idea, not coming from me, is a TV series which I don't watch, but the in terms of this particular scene is quite common with people who have interest in machine learning. So we thought, yeah, why not? It's a good chance to also have a look at that particular the idea from that particular TV series, the scene, and the TV series is Silicon Valley. I'm not going to write it down because basically I'm not here to promote the TV series. Just basically we want to zoom into that particular scene and see what they did. So the whole idea was basically in Silicon Valley, one of the characters used a machine learning algorithm to basically try to go after a real world application, right? And what he created was a smartphone app. Sorry, I need to change the ink so it's a bit clearer. So what he developed was a smartphone app, and basically all I have there is just a drawing of a phone. So for those at the back that is not clear, I would say just bear with my drawing, but at least it's sort of close enough to a mobile phone app, right? So we just have a smartphone app, and from the app, we say with this particular app, we introduce several pictures of food, and when we take pictures of food, the app will tell whether it is hot dog or not hot dog. So with the app, we take a picture, and if it is hot dog, then it will tell whether it's a hot dog. Otherwise, it will just simply say not hot dog. And hence, the creator of the app actually also called the app not hot dog, right? So it's a not hot dog app. So simply hot dog or not hot dog. But then if you sort of look at this, it's sort of yes or no kind of scenario, or 1 or 0 kind of scenario. So we can say this is a 1, that's a 0. That's what the classifier is doing. Just look at the data and simply say, yes, it's a hot dog, or no, it's not a hot dog, right? So basically, that's all has been created for us with this not hot dog app. And if you think about it, if you present it with a shoe, it will simply say not hot dog, right? So basically what he has done is, well, get several pictures of hot dogs and afterwards do some processing with millions of different food pictures of food from online to train the system. So if you're thinking about the app that was created, the model that is using, so he basically take images of hot dogs and images of several food to train the system in order to get the output, which is just hot dog or not hot dog. Can I ask you, is this, will this fall under supervised or unsupervised learning? Wonderful. So we all say supervised learning. That's good. At least it means that we're paying attention or everything is nice and easy. So yes, he's using supervised learning, but actually, if you look at the nature of the data, it's the output is just basically binary nature. It's either 1 or 0, right? It's either hot dog or not hot dog. So it sort of have simply 2 output boxes, just fictional boxes that we can actually fix the output into. So in this particular case, because it's binary in nature, we can say it's binary classification. And my computer is frozen, so give it a bit of time and hopefully we'll be back. It's back up. Yes. So this is binary classification.
Hello, Michael.
Yes, please.
I have a question.
Please ask.
So for this, if you actually bring another breed of dogs, right, which is not hot dog, maybe like German Shepherd, would it still say it's hot dog or not?
Oh, okay. So just some slight clarification. Yes, I do understand your question. So basically, if you think about it this way, let's use let's use a different example. I think that will help. So it's just basically we train the system to identify apple, okay? Whether you like my drawing or not, that's an apple, yeah? So we say we train the system to identify an apple. So all the system does is, or our model does is, it says apple or not apple. So it means that if we present, I don't know, a bicycle to it, it's just going to say, it's just basically going to say not apple. Yeah? If we present a shoe, it will just say not apple. If we present a house, it will just say not apple. It won't be able to identify that, as long as if we have, let's say, different types of apples, depends even if that exists. If we have different types of apple that, and the system is trained well enough to identify this apple and is doing really well, it will still say apple. If the system is not trained properly and it's not doing really well, of course, it will classify some of them wrongly, even though they are. Do you understand that?
Yes, please.
Okay, now in the context of the example and the reason why, just to clarify things, and when you are watching the slides, or if you decide to revise using the slides, I've basically paused the recording. So let me stop this recording so I can go back. But you have the full thing on
if
Zoom.
you think about it, if you present it with a shoe,
sorry. I didn't plan to play. I hate listening to my own voice. But back up now. So I'm going back to the example, right? So basically, as we can see, just think about the hot dog as, I don't know, sausage. Yeah, so it's basically identifying sausage or not sausage. So the classifier is not interested in dog breeds at the moment. It's just basically looking at sausage or not sausage. It's just food, just that there is a particular dog that looks like sausage dog. So basically people sort of compare it to hot dogs. But all we are trying to do is just looking at one particular type of food, which is sausage, and then comparing it to different things. Is that clear also?
Yeah, so I was actually thinking about sausage when you started the lecture, right?
Okay.
But it looked like the hot dog breed of dogs.
Yeah, so we're just interested in hot dog, the food. That is, the app is basically was a really poor app in terms of all it's designed to do is just basically find hot dogs. So if you gave it something else, it wouldn't be able to classify, just simply interested in only one thing. Yeah, so if sausage work, let's stick to sausage, right? Yeah, happy for me to move on. Thanks for your question. Let me get a recording started on this. So yeah, in terms of this, basically all we're using is supervised learning. Sorry, I'll start the recording, get it started. So all we're doing is supervised learning, but it's a particular angle that we are interested in. So we just branch it down because it's just, the output is very binary in nature. So thing has frozen. I'll let it breathe and hopefully we'll come back. Yeah, it's back up. So it's just basically we're doing binary classification at this moment. And remember, we've not picked binary as the algorithm. We've just picked it as sort of a subgroup under the classification. The same way that within supervised, we have two types that we picked up, okay? So basically, if we try to even skip this point, we can't just say that within supervised learning, we have the binary classification, and of course it's a classification, so falls under classification. We've got the multi-class classification, so we have the multi-class. So at the moment, we're just filling in the A and B we created earlier. That's an L and a T, right? Multi-class classification, and then we've got regression. Okay, so our hot dog or not hot dog, we'll jump into machine learning, go to the classical method, goes to supervised, and go through, sorry, I almost zoomed into that speed talking again. I'll slow down now, go through classification, and eventually not hot dog will sit here. Not sausage will sit over there, right?
Michael, please, I have a question.
Please ask your question.
So I watched that episode, right? And in it, I think at a point,
I haven't. Yeah.
I think at a point it got confused between hot dogs and, I don't know if I'm allowed to say this, but like the male reproduction.
Don't say it, but you can continue with the question.
Yeah. So in that end, to solve that, they started training the model with only those two types of images. So I just wanted to find out that when you're doing binary classification, do you just pick any type of data? Because in a situation like that, imagine if you pick the bicycle, for example, it will be easier to tell. So I just want to know if when you are training, you use quite difficult data to interpret so that it becomes more intelligent.
Yeah, thank you so much for your question. Well, if you remember what I said earlier when I was trying to answer, sorry, I didn't get the other person's name. When I was trying to answer the question that came earlier, I kind of chipped in that this is quite done really poorly in terms of the app itself. If the whole goal is just to identify hot dog or not hot dog, then of course you can just go to feed it with as many good training data as possible. And I'm using the word good very loosely here, okay? But if basically reflecting to what we've been saying since day one, the type of machine learning algorithm you go for is mostly dictated by the nature of the data you are working with. Yeah?
Yeah.
Okay. So if you're working with data that can, like we're looking at food at the moment, and that's actually the next sort of slide. But if you're looking at data that sits into maybe hot dog, I don't know, biscuit, shoe, something else, sorry, just randomly making stuff up. It's not necessarily, the data is not necessarily binary in nature. So pretty much, even though you spent a lot of time to build your machine learning algorithm, basically, it is not, the algorithm binary classification is not suitable for this particular application, unless all he was paid to do was just to identify only hot dogs and nothing else. Does that answer your question?
Yeah.
Okay. And of course, if there is a follow-up question, please do feel free to ask. At least, can I know your name? So in case I need to come back to it, and the other person who asked the question as well.
My name is Oyeneba.
Oyeneba, I think this is the first time you're asking me a question, is it?
Yeah.
Or this is the first time I'm learning your name. So Oyeneba, nice to get to know your name. And see, I think you were sitting at the same spot last time as well. So. And the other person, please.
Sandra.
Sandra, I think you've asked me a question before and I've told me your name before. Is that correct?
Yes, please.
Okay, good. At least I remember that one. So thanks, Sandra, and thanks, Ohineba, as well for your question. Is the class happy for me to continue then, or are there any more questions? Okay, so I'll take silence as golden and you're happy for us to continue, unless maybe I've lost your sound or you didn't understand me. So as we've said, binary classification, that's where hot dog or not hot dog sits. So it's just hot dog or not hot dog. The name binary kind of gives it away in the sense that cases where you have the data that looks, well, the outcome that the output you are looking for, the nature of the data, simply look at potential output just going to be 1 or 0. Then you're going for binary classification. Alternatives or similar cases, something like a yes or no. Or you can say, is the student accommodation room available or not? Or do I need to clean my room today or not? Do I need to clean my room next week or not? It's just basically things about rooms, or basically, will I get somewhere temporary to stay today or not? So basically, things where it's simply a yes or no case, or it's just things you can simply answer with yes or no. I don't want to write the whole room thing down. Or basically things like if you go to the stock market and you just simply want to say, yeah, do I want to bid or not? Depends. I don't do stocks, but pretty much for those who are interested in it. So where you want to say something is right or wrong as well is pretty much binary in nature. So all these sort of ones, you're likely to go for binary classification. And I think he fits smoothly into previous question as well. And of course, anything else, go. And Ohineba, thanks for not saying what you said you shouldn't say as well. I really appreciate that. So because this is supervised learning, basically what that means is that someone has to teach the model. You can say model, or we can just try to replace the word model with a computer, but basically someone has to teach the model how to identify the hot dog or not hot dog. Basically, we need to have some form of prior understanding of the data, and we should be able to identify certain features or be able to label the data and feed it into the system. But luckily, we've been doing a lot of supervised learning, so we have seen how this can be done practically as well, or how this is dealt with practically, and how the machine tried to learn through it during the training process as well. So something we just touched on before, or in the previous slide, was the multi-class classification. So is that a question?
Yeah. Hello, Michael.
Hello. Start with your name and let's have a chat.
Could you please go over what you just said?
Okay. But you forgot to tell me your name though.
Daniel.
Hi, Daniel. Is it this one?
Yes, please.
Okay. So we understand binary is sort of base 2, right? So basically binary is 1 or 0. Yeah?
Yeah.
So by name of the type of classification is just basically classification. You either go there or you go there, pretty much. In binary case, it's either you belong or you don't belong, or you belong somewhere else, more or less. So it's either a 1 or 0. And we talking about if looking at the output you are targeting, when will you decide to use binary classification? My wife was funny. Right? When would you decide to use binary classification? We're saying cases where you are potentially to have the output being a yes or no. It's Michael Toll, yes, no, right? Pretty much, right? It's not a continuous data or multiple output that you are looking at getting. It's not about what is the height of Michael and you go to get, or the height of people and you have a wide range. It's about whether tall or not tall, right? And again, we're saying that other similar cases, sorry, my machine has froze. I'll let it give 1 second. Good, we're back. Other cases that we will use binary classification is where you are targeting something that probably is correct or wrong in nature. Or questions like, is the student accommodation room available? Is so yes or no answer that you are targeting. Does that help? And do you understand up to this point?
Yes.
Okay, thank you so much, Daniel, for your question as well. So we were on this slide where we were about to talk about multi-class classification. So I will jump back onto here. Sorry, I need water. So I'll jump back onto this particular slide and say that within that subgroup we've created, right? We've sort of taken classification and we split it into binary and we split it into multi-class. We've looked at binary with the not hot dog application. We want to look at what multi-class is. That's what we're doing. We're going to do from this point. So delete whatever recording was there and continue with the recording, give it some time to get ready, and we will continue from there. It is ready, right? So multi-class classification actually is also another common, like we said, we're looking at the common machine learning algorithm anyway. So basically it's another learning, machine learning problem. Is basically to use multi-class. And this problem actually, this is a problem where you have almost limitless number of outcomes. So when we talked about it earlier, that was trying to identify things beyond the hot dog stuff. So you have several classes that you want to put things into. And again, we're likely to lose the recording. You want to go back and delete it. maybe when I share, I'll share the other classes recording with you because on the slide, I'll probably merge them. I'll fix it. Right. So basically, you have limitless possible categories that you are likely to create. So you might want to imagine an application that looks at an image of food. Similar to, sorry, I said hot dog, we did change it to sausage. So similar to the sausage application, not sausage application. And we want to look at food items, but in this particular case, we want to classify them based on several predefined categories. So some of the predefined categories in this case can be for something like sandwich, or it can be a drink, or it can be cookies or bakeries or biscuits, or whichever works. And again, it's frozen. I'll give me a second and we'll be back. So we've got several, three categories in this case that we can map to. And in terms of talking about limitless possible outcomes, you can even in the drink, you can have fizzy drink, you can have non-fizzy drinks, you can have, I don't know, alcoholic, non-alcoholic, as even other categories that can also fall in there. So because we are not necessarily doing only binary, it is multi-class in nature. Think about it this way. We're doing multi-classification. Is that okay up to this point?
Yes. Yes.
Okay. I'm aware we are on the hour. Do you want a quick 5 minutes comfort break? Was that yes or no?
Yes.
Okay, so let's take a quick 5 minutes comfort break and we should still be able to be on time. So I'll wait for you to take a comfort break. Please do come back in time. Happy for us. Yeah. Can we continue?
Yes.
Okay. So then you have your regression problem, which is where we took linear, but we've looked at it details. So you have, of course, countless possibilities in terms of where it continues. It's got like data, and we try to find line of benefit. But we have looked at simple linear regression practically. So I would say more or less we're happy not to spend a bit more time on that one as well. We've got the practical side that we have done. Then this one, I understand it's not very clear, but I'm going to draw over it. So basically what we have here is a decision tree. And we want to use our decision tree to do some form of classification. So now we are looking at a sample algorithm, right? Not a classification. A sample algorithm that will fall under one of the classifications that we've got. And we have looked at trees in the earlier week as well, so it makes life a lot easier at this point. Sorry, my drawing is horrible, but hopefully you can see it a lot better now. Yes. Yeah, hopefully it's clear. So basically, decision tree is used for binary classification. So if you want to go through several scenarios or try to see patterns on the data in order to simply try to arrive at a yes or no, is one way of doing that is using decision tree. And of course, it falls under supervised learning as well. So basically, we've done decision trees. We know it's quite fun. We want to have a look at an example where we decide whether Yash goes to the beach or not. And we have certain predictors. Think of it as the basic features that you look at in order to determine whether Yash will go to the beach or not. You can replace Yash with any name that you want, or any name that makes sense. Hopefully you can still understand me when I speak at this pace. Is that okay?
Yes.
Okay, so we have three predictors that we want to look at. We want to take maybe the sky, weekend, and then also look at the wind speed as well. So if we look at the data, the known data, our understanding, the data that we really understand, which is about Yashi's behavior, we notice that Yash goes to the beach, doesn't go to the beach when it's sunny, and it's a weekday, and then with the wind speed is low. The same way you've got characteristics go on, but we see this in the tree. Basically, we feed these contents into a tree to see how the tree goes. So we just also look at something like in terms of the sky condition, whether if there is an overcast, and of course, it's a weekday, and you can replace overcast with any other sky condition you want. That makes more sense. Or whether, again, my machine has frozen, so give me a time. 1 second, and it's back. So whether it's a weekday and then the wind speed is low, then Yash goes to the beach. So we have this data, some kind of ground truths, what we already know about Yash's behavior and going to the beach, right? So to create the decision tree, we just basically take this data and we split it based on our predictor, right? So we will take a predictor. So let's choose a predictor. It can be any of the predictors. And in this particular case, we will take sky. And again, I'll give you 1 second to unfreeze. Okay, we back up. Sorry, that's just because it froze. So we take sky as our root node, and then we should also, of course, just think of the node that gives you basically the best possible outcome. So the root node that is very trying to give you the right tree. Anyway, think of it as a triangle tree. So basically, we say we have our sky, and then we will branch out into various connections that we have based on the data or what the data looks like. So if we take sunny from sky, we've got sunny, or we've got rain, and then we have overcast, right, as a branch from it. So in this particular case, these are the three possible outcomes from sky to the next level. Can I double check? Are you okay with this, Faith? And are you happy for me to continue?
Yes. Okay.
Okay. So basically, we have, we just break it down more, right? You can see the boxes around them. So we've got the sunny, and then from sunny, we can actually say whether, depending on the nature of the sky, if it is sunny and it's a weekend, from the data we had earlier, again, it's frozen. Some fruits. Okay, good. The possible outcomes, right? The possible outcomes when it's sunny and a weekday, from the data we had, was no. If it's sunny on a weekday, the possible no's and the possible times that Josh didn't go to the beach was 0 times. So pretty much, well, he actually didn't go to the beach twice. We have 2 counts that Yash didn't go to the beach on a sunny day during the weekday, right? And if it were sunny and it's weekend, the outcomes there, so it's just the same, another outcome, so it's Tito in there. If sunny on a weekend, Yash went to the beach on 2 counts from the data that we have. And there was no instance that Yash did not go to the beach. That gives us a good indicator of Yashi's behavior as far as the beach is concerned on a sunny day. So we can naturally say that on 2 occasions on a sunny day, Yash did not go to the beach, and on 2 occasions, Yash went to the beach. Let me go back. Bear with me. I'll stop the recording and go back. So hopefully we can write on this. And again, if we pick the rainy days, there was no instance that Yash went to the beach on a rainy day. Of course, this is coming from the country data that we know. So there was no instance that Yash went to the beach. So it was 4 counts of no for a rainy day. However, when it comes to the overcast, we had the high wind. There was on a high wind day, when it was really windy, there was no day that Yash went to the beach. Whilst on 2 counts, of course, he did not go. So this, we had 2 windy days, but Yash did not go to the beach. So that's the outcome. However, on low winds or less windy days, Yash went to the beach once. And at the same time, on another day, he did another, no, not windy, so windy day, Yash did not go to the beach. So that's interesting. There are clear cases that you can actually see that, of course, you can learn about Yash's behavior, and it allows us to simply reach the yes or no answer based on the data that we use, whether he went to the beach or didn't go to the beach. So has helped us to do some form of binary classifications. Let me do this for the purpose of those who are writing or wish to write. So we have 1 yes and then 3 no's. So I'll put 1 yes and 3 no's there. Over the gray thing to make it well. So of course, basically we have the decision, and it's actually based on the training data that we are providing. And of course, we have 3 scenarios that Yash went to the beach and all this happened. The good thing about this is that you can easily visually see, and then it's a lot easier for people who are, of course, non-machine learning experts to easily understand what is happening to the data. So if I'm to go on to a couple of say that if you are struggling to arrive at your yes or no, that means that you have a lot of entropies in your tree, right? So in the data itself and on the tree. So if you look at this particular data, again, it's frozen. So give it a bit of time, then it keeps freezing. Yeah, there we are. So if we look at this particular scenario where we have the windy days. So we go through the sky down to the windy days. We have a case where it's kind of inconclusive whether Yash will go to the beach when it's a windy day or not, because there was a day he did not go and there was another day he went. So if you have a lot of these in your tree, it will be a bit difficult to actually make some conclusive decisions. So what you can actually do, of course, you can pick a different predictor to use instead of the sky, or you can decide that you get rid of windy day from your decision tree. So it makes life easy for yourself, and you can use others to make that decision for you. And I believe we are right on time. And the next topic I wanted to cover was K-nearest neighbor, but we will actually cover that in the next session. And actually, I'll say we are just on time, and I think I'm happy with where we are now. But I'll pause for any potential questions, anybody who wants to ask questions. And of course, if you want to leave also, I completely understand because it is time up, and you can also send me your questions as well.
Hello, Michael.
Yes, please.
Yeah, I didn't quite hear the word you were mentioning. Was it windy back or?
Okay, so it's just an example, and we are thinking of on the day if it is windy or not. So if it is high wind, think about it as raining or not raining. Some examples like that. We've got raining or not raining, sunny or not sunny. So if it is windy or not windy, if you have high winds or not high winds. And from airport, I think that's the P. I can only say the P. I don't know any other language.
Okay, thank you.
All right. Thank you all so much. If more questions, please throw it at me. Otherwise, I'm more than happy for us to end the session.
Hi, Michael. Please, I have a question.